Yeah. Okay, guys. Another little tutoring session here. I just want to go over some of the stuff that will get you ready for the test. So just know this is the periodic table you'll get for the test. It only has the symbols and atomic number. But I'm going to show you how you can use this to ace this test. So you get hundreds, please. Hundreds. Although I saw some of you falling asleep today. What's up with that? Okay. So here we go. We're going to go through each of these. Some of them I'll skip because it was covered in another tutoring movie. So here's how you can use your periodic table to pretty much figure out all this stuff and the kinds of problems you'll get. So you can pause this and just read this list. I'm going to go through each one at a time. Okay? All right. So I have it over here in the corner, but so let's see what color I have here. Beautiful. Black. Alright, let's start with the first one. The first skill you need using this little periodic table is to determine the atomic mass. Let's just go over a couple of things. If you have an element like lithium, I love using lithium because it's like really easy, like this. If you have this guy, lithium, there's a couple of things you can tell just from its number 3. The first thing is you'll be able to know that it has 3 protons. Atomic number is the number that it's in the periodic table, is the same as how many protons it has, 3 protons. Now neutrons can sometimes be the same like this. Neutrons can be 3, and so I would put a 6 up here. Remember we learned that. But sometimes some of you are like so like you're hating that sometimes I do this. 5 neutrons. 5 neutrons. Oh my gosh, I blasted it. 5 neutrons. Oh boy. Hold on a second. Still learning there. Okay. Ta-da. Ta-da. 8. So number of neutrons doesn't have to be the same as protons. And so sometimes you get something that's easy like 6 up here, but if you get an 8, that tells you that you have what's called an isotope. An isotope is a version of the element that has probably extra or a different number of neutrons. So you can have like 3 here, you can have 4 here, you can have 5 here. Okay, so those are called isotopes. So knowing that, if I give you one of them, like if I just give you neutrons, you can figure out total mass, protons plus neutrons. And that gives you 8. And that's why that's here. The other thing I can give you, erase this whole thing, let me use my big eraser, is that if I said lithium is 3, and I put 4 up here, sorry, that's dumb. If I put 7 up here, or if I tell you its atomic mass is 7, you can tell me how many neutrons this has. Because 7 minus 3 is 4. 4 neutrons. Another way to think about it is 3 plus something equals 7. Got it? 4. Cool? So that's how you figure out this. You can determine atomic mass or number of neutrons just from one number. Now I have to give you either neutrons for you to figure out the mass, or I have to give you the total mass for you to figure out neutrons. Groovy? Groovy. Alright, so that's number 1. Cha-ching! Number 2, valence. Remember we folded our periodic table to exclude this metal section, and that gave us perfect rows of valence. 5, 6, 7, 8. Just like that. That means whatever group or whatever column the the element is in is how many valence electrons it has. So I'll give you a couple. We'll do phosphorus, magnesium, fluorine, helium, and xenon. Phosphorus. I look it up. It's there. It's in the 5th column. The valence. I'll put valence here. Valence, 5. Magnesium, 2nd row. Valence, 2. Fluorine, 7. Helium. Wait, I want to write 8 because it's in the 8th row. If you write 8, you'd be wrong. The reason is helium can't hold 8. It's actually a weirdo too. Okay? So be careful with helium. Xenon, however, is down there. It has 8. Cool? So helium, be careful with helium. Okay, cool. So that's number 2, determining valence. The valence is the outermost electrons. Next. All right, the next one is determining the number of electrons in a neutral element and determining the number of electrons in the ion of that element. So let's use K right here. Okay. Potassium. So potassium's atomic number is 19. If you had to figure out number of electrons in this entire element, now 19 is 19 protons. Protons are totally positive. That means there's 19 positive things in this atom, in this element. If this guy's neutral, that means he has no charge whatsoever. He would have to have 19 negative things. Those negative things are called electrons. So, in a neutral atom, protons equal number of protons equals number of electrons. Cool? So if on the test I ask you, hey, there's a neutral nitrogen. How many electrons does that guy have? Total electrons. 7 protons, 7 electrons. Cool? All right. So that's easy. But if you get into ions, it gets a little complicated because you have to understand a couple of things. First of all, you have to know what an ion is. An ion is anyone like these guys here. Not you. These guys, which I said were on the test, these guys have 1 outer or 2 outer electrons that they want to get rid of. When they get rid of them, they get a charge. So let's try magnesium. Magnesium is here. Magnesium has, how many does it have? Okay. It's got 2 valence electrons, and it wants to get rid of them. So it's going to end up having a 2 positive charge. You put a 2 plus. Now the question always is, if magnesium is losing something, how can we put a plus? And it's because, hey man, they're losing these 2. If you lose something that's more negative, you're going to get something that's more positive. So you have to know the charge, first of all. You have to know how many it's losing to know total number of electrons in a magnesium ion. Now, if it was normal magnesium, let me erase here so we can see the number. If it was normal neutral magnesium, it would be 12 protons and 12 electrons. But it's not. It lost 2 of them. So the total number of electrons in magnesium is 10 electrons. Do you get that? I hope so. So let me give you a couple more of those. What are the total number of electrons in these ions? Here we go. O2 minus, F minus, how about calcium 2 minus, and potassium plus. Here we go. Oxygen is here. It normally has 6 valence electrons, but it's getting 2 more. That's why it's 2 minus. So how many electrons does it have now in its outer ring? It's got 8. So its total number of electrons went from 8 to 10 electrons. It got 2 more extra ones. Fluorine, that guy had, fluorine has 9, but it just gained an extra one, so that's 10. Calcium, oh, I can't even see that. Calcium is 20, but it loses 2, so that's 18. By the way, this should be a plus here. Sorry. 18. And potassium, it lost 1. It's at 19, so it's going to go to 18. Okay, notice these 2 have the same amount of electrons because they want to be like argon. Oh, isn't that nice? Okay, moving on. Bohr diagrams. I'm going to skip this because we just did a video on this. So, cha-ching, cha-ching, cha-ching. See the other video. Ionic charges, I've already mentioned that. Ionic charges are These guys all in the first row are going to be plus. These guys in the second row are going to be 2 plus. Aluminum's going to be 3 plus. Ignore, ignore, because they don't usually gain or lose. 2 minus and minus. Okay? These guys have no charge because they have a full 8. So those are the ionic charges you need to know. Ionic formulas you do like this. I will give you 2 elements like potassium and oxygen, or calcium and sulfur, or sodium and chlorine. So here's how it works. The first thing you need to know is their charges, which we just did. Potassium is in the first row, so it's got a plus. Remember, we don't write ones in chemistry, that's why. And oxygen's over here, it's a 2 minus. Using the crisscross rule, you would need, first I'll do the crisscross rule, and then I'll explain why we use the crisscross rule. The formula, the ionic formula for this guy is K2O. Crisscross rule, put this number down here, and put this 1 over here. Put that number there. No charges now. This guy's totally neutral. Now, why is it K2O? To know the science of that is just think about oxygen, this big fat oxygen right here, has a 2 minus charge. You need 2 Ks to hang out. 2 Ks will hang out with this guy because he's a 2 and they're 1, 1. And so this guy is K2O. Okay, that's why it's like that. Now, next guy. CAS. S is here, it's 2 minus, and Ca is 2 plus. So those guys at them being 2 plus, 2 minus, when these two combine, they'll combine as CAS. Now some people ask me, how come it's not Ca2S2 if you're using the crisscross rule? Well, think of it this way. One guy is totally 2 positive and the other guy is totally 2 negative. Just 1 and 1. They 1 and 1 hang out. If that bothers you, you can always do the crisscross rule, and if they're the same, just think of them as canceling out. CAS. And last but not least, salt is the easiest. Sodium's in the first column, chlorine's in the 7th column. It needs only 1 more electron to be happy, so you write it as NaCl. If on the test you put them together and you show charges in there, it will be wrong. Once they combine, they have no charges. If the ion is by itself, it will show a charge. Okay, so be careful with that. Last but not least, Lewis dot and covalent. For Lewis dot, I'm going to ask you to give me the... Lewis dot is a convenience way to show valence electrons. So I'm just going to give you something like this. Like I'll say, give me the Lewis dot for neon, oxygen, nitrogen. What you do is, here's neon. Neon's in the 8th. You're just showing the valence electrons. So neon has 8. Oxygen has 6. Like that. Now there's a way you're supposed to do it. Like you're supposed to go around 1, 2, 3, 4, 5. I'll show you that way so you can sort of... But I won't penalize you if you're supposed to go 1, 2, 3, 4, 5, 6, like that. Okay? But 2, 2, 2 is fine for now. When you get to chemistry, your chemistry teacher will hurt me. And nitrogen. Nitrogen has 5. How do I know it has 5? It's in the 5th row. 1, 2, 3, 4, 5. Okay, or better is 1, 2, 3, 4, 5. Cool. Now, let's start with nitrogen. This also helps you figure out how these things bond. So nitrogen actually has some guys that are hanging out here. It doesn't want 5, it wants 8. So it will share with other things. For example, these H's here. This is a covalent bond for NH3. So I will ask you to, I'll give you this, and you have to draw this out. Now the way you do it is, usually the one that's alone goes in the middle. So if I do CO2, the one that's alone goes in the middle, like this. Okay? This is wrong, by the way. This will be a double bond. I'll show you in a second. Okay. Yay! So here are the ones that you have to know how to do covalent. Please show me water. Who else? I want you to be able to do O2, NH3, CH4. And then this guy's a double bond, by the way. Double bond, and then CO2 is a double bond. I'm not going to ask you for triple. So that's what you need to do. So let's do them so you know what they look like. This is water. Show the extra dots. O2 looks like this. It's a double bond. Everyone's happy here. CO2 is a double bond, so do that guy like this, and then leftovers. Carbon has 4. Oxygen has 6, but they hang out like this and they're happy. So that guy looks like that. NH3 I just did a second ago, and CH4 is very easy. CH4 is 1, 2, 3, 4. No dots, because everyone is totally full. Okay? So that's Lewis dot and covalent bonds with a couple of singles and a couple of doubles. Okay? Alright guys, good luck. Very nice.